put the recording on, and then I'm going to share my screen. And so it's the second week of the course, and hopefully you have all started doing the exercises and started with materials. And so basically what we started with last week, or what you started with last week, because what we did was to just talk about the practicalities, but hopefully you have started with the materials and the things happening in the first week where or the concepts there in the first week. There was the outputting data with the print function. So how to display, how to send messages to user, how to display something on screen, and then sort of like the vice versa, the other side of the IO, the inputting data from user. So we basically started by reading string type data from user, stuff like name or address or something like that, and then connected to that were the variables, so how we can store data temporarily in our programs, which is essential so that we can actually do something with the data later. And then a bit more about reading data, about reading integer type data. So we started by reading string type data, and then there's the int function we can use to convert the data into integers. A little bit about formatting output. We will talk about that more about that later, but stuff like how we can display strings and numbers with the same print statements. And then a very simple conditional statement, which is basically what we're going to continue with this week. There's a question on that: when will the results of the exam be announced? The initial exam results will be announced today, later. I have checked most of them, I think, and I will check the rest of them after this lecture. So this afternoon, if you attended the exam, you will get an email about it later today. Some questions on the feedback. There were, for some reason, several questions about whether we have a Moodle page. No, we don't. We only have the material page. I think it's important that we only have one or as few shared communication channels as possible, so that everyone knows where to find the information. If there's something missing on the course page, again, let me or the other instructors know so that we can update it as soon as possible. Do you have any questions about the practical stuff on the course? Now there's a question. There's a question whether it's possible to replace Java 1 with this course. This is actually something you should probably ask from someone who's responsible for the Java course. Maybe send me an email about that one. It's probably easier to sort it out. Any other practical questions at this moment before we go to this week's actual topic? Okay, then let's start. There's, in the beginning of this week's material, the first page is about some terminology concerning programming. And when we were writing the material, we were sort of trying to find a proper balance between teaching programming and then teaching some of the theory behind programming or terminology is little bit, probably belongs a little bit on both of those categories. But there are some important terms which will be repeated over and over again with the material, and I think it's important that you know what most of this means. At least you have some kind of vague idea of what this means. And let's talk about this briefly. so we talk about statements, and statement is basically a part of the program code that performs a single function, performs a single action. So statement can be something like print or calling a print function, something like this, or it can be an assignment, something like number equals 23, or name equals the Python, or something like that. Or it can be something a bit more complicated, like a conditional statement, an if statement. Something like this, and basically in this case, this whole thing is a conditional statement, and then there's another statement inside this or after this sort of condition in here. So it can sometimes be a bit complicated, and even computer scientists don't always agree on how you actually define what is a statement in all cases. But the basic idea is that statement performs a single action in your program. Then we talked about blocks last time, and again, in Python, block is a program code that sort of belongs together. So what we can say is that, for example, there is a block following this if statement here. So the program code in lines 7 and 8 belong to the same block. And in Python, this is the block is actually denoted with the similar indentation, meaning that the lines with the similar indent belong to the same block. So basically, in this case, all these lines here belong to one block, and these lines here belong to one block. And typically we use these blocks after, for example, conditional statements to notify Python that this code needs to be executed only, for example, in this case, only if this condition is true. Then we talked about expressions briefly, and now expression is something that can be evaluated, and when it's evaluated, it results into a value. So basically, expression could be a mathematical expression, something like 23 plus 11. So this is an expression here, and when it's evaluated, the result is integer 34, if I'm right. And so that result can then be stored, for example, into variable in this case. Expression can be something not mathematical, like this one, where we concatenate these strings to form a new string. So basically, we take three strings and create a new string out of those three existing strings. So this expression evaluates into another string, be it a Python with space in between. Assignment doesn't. There's a question: does assignment evaluate to anything? Assignment as is doesn't really evaluate to anything. So number equals something doesn't evaluate, but what it does change the value of a variable. But the assignment itself doesn't evaluate. So basically, the expression on the right-hand side of the assignment is evaluated, and then the return value is assigned. So yeah, A equals B equals 1 doesn't work. No, it doesn't work in Python. So assignment doesn't have a return value, or doesn't have a value. But that's actually a good question, because in some programming languages, assignment actually does have a value which can be assigned to something else, but in Python it doesn't. Then we talked about functions. Oh no, let's continue on expressions a bit. We also have conditional expressions like this one in here. And the conditional expression is distinguished with the fact that it has a conditional operator, something like equals, or not equal to, or larger than, or smaller than, or what is it's greater than, not larger than, but anyway, greater than or smaller than, or something like that. And when we have an expression which contains conditional operator, then the result of that expression will be a conditional or a Boolean value of true or false. And these expressions are typically used in conditional statements. But we can do something like this as well. well, let's start with this one. What will the program output? Yeah, it will output true, as we see over there. If we change this to like this, then it will output false. So basically, we can assign the value of conditional expression into a variable as well, like in this case. And what happens here is that the conditional expression is evaluated into true or false, in this case into false, and then that value is assigned in the variable. And then we can, of course, use that use the variable like we use any other variable. So we can say something like this. So what will the program output? Yeah, it doesn't, nothing is true. It doesn't output anything. So basically it doesn't output anything because the value of variable truth is false. And then we remember how the if statements work. So if the expression, if the value of expression is false, then the block following the if statement is not executed at all. So in this case, it just skips over this one. If we change this to something that's true, like this, for example, now this expression is true because 12 times 2 is 24. Then it when we execute it, then when we execute it, then it outputs it's true. There was a question about string formatting. It's something we're going to talk about later in this course, but to answer the question, we are using the F strings ourselves in this course later in the material. So we use the second one you provided in the chat. So, but they will be included in the material. I think it's next week or week after that or something. So let's talk about those together later. Then a couple of words about functions. We've been using some functions before in Python. For example, print is a function and the input is a function. Input is also a function in a sense that it returns something. So if we have an input statement like this, and this is something you've all been doing. So if we execute the program, then it queries for a name. And then what happens in here is that the input function queries the user for a name, and then it returns the name given by the user. And then that return value can be stored into variable, like in this case, into variable name. And then we can use the variable later to access the data, which that variable references. So the functions are typically given parameters. Like in this case, the input function gets a parameter, and the parameter is this string in here. And with input function, the idea is that this is the message displayed to the user to sort of give a hint about what kind of information the user is supposed to give. And then functions often can return values. Like in this case, this returns the string given by user. There's a question that why do you always make a space after the colon? I think it's just to, I think it's a bit easier to sort of, it makes it a bit nicer looking if there's a space between the colon and the data given by the user, but that's just I think that's sort of like an opinion, that there's really no any syntactical or any like reason Python would. So this works exactly similarly if I remove this one. It's just that in this case, the text the user gives comes directly after the colon like this. So I think it's sort of easier to read if there's one space between the colon and the data given by the user. Okay, anyway, we're going to talk about functions more. We're going to talk about writing your own functions a lot in this course starting from next week. and especially the week after that. And the basic idea is that we learn how to define the functions where we can provide parameters, and we know how to know how to return data from functions. And yeah, it's true that input works without any string actually. But what we usually want to, why we usually want to pass a parameter to the input function is to provide some kind of information to user on what kind of data he or she needs to type in. Then type is something we have discussed briefly. In Python, all the objects have a type and all the variables have a type as well. And in this case, for example, if I hover the mouse over a variable, like in this case, it displays the type of the variable. In this case, it's str, which is shortened for string, meaning that name is a string type variable. In Python, you don't need to define the type of the variable yourself, like you need in various other programming languages. Instead, Python automatically determines the type of the variable based on the type of the object you assign into that variable. We can also, so we have other types than string. We have number type, integers type, for example. So if we have a number, then the type is int, stating that the data stored into that variable is integer number, or we can have a floating, something like this one. In this case, Python automatically figures that money, the type of the variable money is float, so it holds floating point type of data. And all the Python variables, all the Python objects have a type. And although we don't usually explicitly define them ourselves, instead Python defines them for us. But it's important to realize that there are different types of objects, and it's also something we're going to talk again a lot more later. Excuse me. Then syntax and oops, there's some Finnish language over there, which is of course not supposed to be there. Anyway, we talk about syntax a lot, and programming languages like natural languages have a syntax, meaning that there's ways things need to be written so that Python understands what you mean. And the programming languages are usually quite strict with the syntax, meaning that if I want to output the message, want to call a print function, need to type it exactly like this. And if there's something missing, for example, if there's a parenthesis missing, then Python doesn't understand what I mean, because that's important part of the syntax. And the same, if I, instead of print is, if I misspell it, there's p missing or something like that, then it's also Python don't understand the syntax. Or capital print, which is that's actually a good example. If I write it with a capital P, then Python doesn't understand what I'm trying to do here in this case. So the syntax is really strictly defined, and it's actually quite typical that, especially when you're writing your first programs, but even if you are an experienced programmer, you do make a lot of these syntax errors. These editors, for example, Visual Studio Code, which we are going to use starting from week 4, usually make it easier. So if I try to assign something and I make an error, I have 2 of these equals characters in here, then it displays some kind of error message, at least, whether it understands or, I mean, the actual message might be different, but it sort of, at least it tells you that it doesn't understand what you're trying to do. There were some questions. Are there any other data types in Python, like long int or short int or unsigned variables? There are some. Python has long integers, but you don't need to. It makes a conversion itself. So type of 120 is. There is my. Well, I can do it. There's a type function in Python which gives you the type of any variable or any object actually. So type of this is int, and then if it's long enough, then sorry, I just ignore what I just said. This was actually changed in Python version 3 at some point. So it's just int regardless of how long it is. So it doesn't do the conversion anymore. And so basically, and Python doesn't have unsigned integers either, unless you're using some specific external libraries to accomplish that. So basically in Python, to make things easy, the basic idea has been to have as few types as possible. So the basic types are there are integers, there are floating point numbers, and there's only one floating point number. So there's not like a double precision floating point number or anything like that. And then there's a Boolean and strings basically, and we get quite far with that. But let's talk about that again in more detail later. Anyway, the syntax is important, and then we talk about semantics sometimes, and semantics of course means the meaning. So we have a syntax which defines on how we need to write something, and semantics which defines on what happens when we execute the code. And finally, debugging is a really important part of any programs. What it basically means is finding errors in your programs. And as I said last time, I think writing programs, the process of writing programs is usually this sort of recursive one, or like a cycle where you type in some code and then you test the code and then you fix the errors, and then you keep on doing this until you have a program that actually at least seems to do what you expect it to do. Anyway, as I said, these are some of the terms we use quite a lot in the material in the upcoming weeks. So it's important that you know what we mean by these, but they will also get familiar to you when we use this or when you encounter them in the material. So you don't need to learn them all right now. Just it's something to start learning, or some of these you probably have learned already. Okay, then let's continue on the actual code writing things, or with the actual code writing things. Last week we talked about conditional statements, a little bit about conditional statements. The idea is that let's write a short program. So let's query a number from the user and then convert it into integer by using the int function. So something you did at last week, and then we can use a conditional statement where we define that we have some code which we only want to execute if a certain condition is true. Something like if number is smaller than 0, print it's a negative number, like this. And when we execute the program now, if we provide a negative value like -5, it outputs the message. And if I execute it again, and if I provide a positive number like 5, then it doesn't output anything, because the idea of this if statement is that this code in the block following the if statement is only executed if this statement here is true. I might have some problems with my internet connection in here at the university. So if my voice is disappearing or something, let me know immediately so we can try to fix it or something. Okay, so anyway, it's quite typical that we want to provide several, or want to sort of look at several different outcomes of a condition. So let's say that we want to check if a number is a negative number, and we want to also find out if it's a positive number. So we want to do something different with negative numbers and positive numbers, for example. And what we could do is write 2 consecutive if statements, something like this. So we could have a conditional statement where we check if a number is more than 0, and then another conditional statement where we check if the number is larger than 0, like this. So we can test this out, and then this seems to be sort of working as intended. For 15, it displays it's a positive number. For -15, it displays it's a negative number. Now there are some problems with this one. Let's start with the first one. The first one is that let's say that we are writing a program where we're really interested on the value of the number instead of sign of the number. So if we get a negative number, we want to convert the number into positive number and then keep on working. So if the number is more than 0, we could write something like number equals minus number, or number equals number times -1, however we want to do it. Anyway, however we want to do it, we want to convert it into a positive number by multiplying it with -1. And then we want to keep on, let's move this message, doesn't really matter, but over there in this case. And then we want to continue. Let's say that we want to then calculate that, well, let's not do anything yet. Anyway, let's say that if this was an actual program, then we would continue on processing the number. So what happens now if let's try this program. So if I give a positive number, it displays it's a positive number. What happens if I provide a negative number? Yeah, it prints something. What does it print? Yeah, it prints it's negative. Okay, let's try it out. I provide -15, and now it displays that it's a negative number and it's a positive number. Why? Why does this happen? Yeah, you're all basically right. So there are 2 if blocks, and now if the number is a negative number, it first enters this one. And because number is a negative number, then this condition number is smaller than 0 is true. So it executes this block. So it first outputs that it's a negative number, and then it multiplies the number by -1, or does the number equals minus number. So it converts the negative number into positive number. So when we enter the second if statement, then this one is true as well. So the negative number became a positive number, and now this also displays it's a positive number. And in this case, we probably wouldn't want this. What we probably want is a program where we execute exactly one of these blocks. Okay, yeah, let's talk about that later. So instead of having 2 if statements, we can replace the second if statement with an else block. And the idea of the else block is that if this condition is true, then we execute this block like we did before. If it wasn't, and if there is an else block, then we execute this one. So basically we define that there are 2 blocks, and with each possible input value, we execute one of these blocks, either the first one or the second one, but it's always one of them, exactly one of them, not both, and not either, but always exactly one of them. Let's try it out. Let's give a number. So it's a positive number, it displays it's a positive number, and then if I provide a negative number, it displays it's a negative number. So it basically seems to be, it probably works better. It sort of depends on what we're actually trying to do here. But the basic idea is that there is exactly one of these blocks that needs to be executed. What happens if I provide a 0? What does the program print or output if I provide a 0 as an input? Okay, let's try it out. You're absolutely right. It outputs, I'm supposed to give a 0 like this. Yeah, so it outputs it's a positive number. Why? Why does it think that 0 is a positive number? Yeah, that's actually a very good answer. It belongs to else, and that's exactly what happens here. So what we state in here is that if this condition is true, let's execute this block. And in all other cases, if this condition isn't true, then let's execute the else block in this case. So, and 0 isn't smaller than 0. 0 is exactly 0, but it isn't smaller than 0. And that's why this condition is false, and that's why it executes the else block. And now there's a, in chat window, there's a great recommendation on how we can fix this one. So instead of, so basically, if you think about this kind of case, there are actually three sort of different cases. There are negative numbers, positive numbers, and zero. Zero, in especially in computer science, is sometimes considered as a positive number or sometimes even as a negative number. But let's say that we want to distinguish between negative numbers and positive numbers and zero. So what we can do is add another condition. So let's check if the number is larger than 0, then it's a positive, and displays a positive number. And then if it isn't, then it's a 0. So elif is basically shortened for else if. And again, in a lot of other programming languages, we use the else if. But in Python, it's shortened for elif. And now the idea of elif is that, again, it needs to come after an if statement. There can't be an elif statement, like there can't be an else statement if there isn't an if statement before those. But because there is, what happens is that if this condition is false, then Python checks that if the condition in elif is true. So this condition is only checked or only evaluated if this one was false to begin with. So if the number is more than 0, then it executes this first block in here, and then the execution continues after the whole if statement thing, or after the else block in this case. If this one is false, then it checks the second condition. And if all of these conditions in if and elif are false, then Python finally executes the else block. So we can test it out. Can we? Yeah. So it's 1 is a positive number, minus 1, 2, 3 is a negative number, and now for 0, it executes the final block stating it's a 0. So basically the else block is executed if none of the conditions before that were true. You can have any number of elif statements after the if statement. So 0, 1 or more, and there can be an else statement after the final elif statement, but it's not necessarily. So this is perfectly fine as well. If you don't want to do anything, if the input is 0, then we can do something like this. So this is also a perfectly valid construct in Python. And as I said, there can be more than one elif. We can try something else. Check that if the number is 1 exactly, output 1. If it's 2, then let's output 2. If it's 3, then let's output 3, and let's not over continue. Output something else like this. So basically now we have 2 elif statements accompanying the first if statement. And again, the same basic principle. If this first condition is true, let's add a print statement here. Something like this. So if the first if statement is true, then this block is executed, and then the execution continues in here. Again, if it isn't, then it checks the second condition and so on. And if none of the conditions here are true, then it executes the else block. Oh, there's one semicolon. Yeah, it's not supposed to be there. That's a good catch. So if we execute the program, let's try it out. So if I give 1, it outputs 1, and then it outputs always outputs thank you for running this program message. For 2, it outputs 2. For 3, it outputs 3, and for anything else, it outputs something else, and thank you for running this program. So this whole if, elif, else construct means that, again, exactly one of these blocks is executed each time, depending on the input in this case. But it's either this one, is line 4, or line 6, or line 8, or line 10. Exactly one of these blocks is executed, never more than one. And but always exactly 1. So what this means is that we can write if statements, more sort of like versatile if statements, where we check for several conditions instead of just finding out if a single condition is true and then outputting or executing some code based on that one. We can actually check for several different kinds of conditions, which are usually somehow related to each other. And we can also have an else block, which is like, if none of the conditions are true, then execute this one. Okay, here's also directly from the material. Here's also a sort of a flow chart visualizing this one, what it happens. So, or it's actually more. Where is it? I don't have a picture for that one. Probably not. Okay, anyway, let's move on. Often it's also a good idea to be able to chain several conditions into a single condition. And what I mean with this one is that we may want to combine conditions, something like we want to know if a number is between 1 and 10, for example. And if you think about it, that's actually 2 conditions. So the number to be between 1 and 10 means that the number needs to be greater than or equal to 1, and it needs to be smaller than or equal to 10. So it's not possible to write just a single condition. At least it's not possible with the tools we have at this moment. Write a single condition that checks if the number is between 2 limits. Instead, we need to have 2 conditional expressions sort of combined together. What we can do is write something like, if number is larger than or equal to 1 and the number is more than or equal to 10. And then we know that number is between 1 and 10. So let's try it out again. So if I give something like 5, that's between 1 and 10. But if I give something like 15, then it doesn't display anything except that this thank you for running this program message. So at the end of the program. So what we have in here is this and sort of, as I said, it combines 2 conditions. There's a conditional expression, number is larger than or greater than or equal to 1, and then it's combined with this number is smaller than or equal to 10. And the idea of AND operator is that the whole expression is true only if both of these expressions are true. If one of these is false, then the whole expression is false. And this is actually similar to what AND means in the real world outside programming languages. If you think about the statement, something like the cup is red and the cup is on the table, that whole statement is true only if the cup is red and the cup is on the table. But if the cup is blue or the cup is somewhere like on the floor or something, then the whole statement becomes untrue. So all the pieces, both pieces need to be true so that the condition is true. And it's actually sort of displayed in this one. So there are 2 conditional expressions, A and B, in this one. And only if both of them are true, then A and B is true. If A is false or B is false, or they are both false, then A and B is also false. Something like this is actually quite sort of common way to use the AND operator to find out if a number is between, or if any value is between some other values. And it could be something like a number between 2 numbers, or a string alphabetically between 2 letters or something like that. But these conditions don't need to be connected. So we could query the user for a name like this, and then we could write something like, if number is 5 and name equals Paula Python. Then again, this whole expression, this whole conditional expression in here is true only if the number is 5 and the name is Paula Python. So if I execute this one, and let's provide both of them 5, and oops, it needs to be written exactly as it is Python, then it displays both were true. But if the number is 5 and name is something like Peter, then it isn't true. Or if the number is 6 but name is Paula Python, then again the expression is untrue or it's false, because as I said before, with AND operator, both of these operands, both of these expressions which are connected need to be true, so that the whole expression is true. We also have an OR operator, which is somewhat similar, except that with OR, it's enough that if one of these is true. So if number is 5 or name is Paula Python or both, then this whole thing is true. So if I try this one, so if a number is 5, then it doesn't really matter what I give as a name. It's anyway, it's going to be true. And if the name is Paula Python, then it doesn't matter what the number is. Yeah, it still claims that both were true, because with or if they are both true, then this is also true. So with A or B, it's only false if both of them are false. And this is not exactly equivalent to, I mean, if AND is equivalent to like real life counterpart, like the cup is red and the cup is on the table, then in real life, we often say that cup is red or cup is on the table. But if they are both true, it might mean that the whole sentence isn't true. But in programming, A or B means that it's true if either A or B is true or if they are both true. And the final logical operator is the NOT operator, which we can use to change the value of false into true or true into false. So basically, what will this output? A bit more complicated, actually. Yeah, it outputs false, and it outputs false because 3 is larger than 2, so this evaluates true, and true is stored in the variable value, and then the NOT changes the value of true into false, which is then output. Don't use it like this, but it's handy in some cases when we want to check for negative values or want to check for false values, and there are definitely occasions where NOT is useful. But I think the not equal to operator like this one, like not equals something, is probably more or often used more often than the actual not operator. But it has its uses, definitely. In Python, you can also chain conditions. So let's get back to, oh, come on, let's write something. So let's query for a number, and then we want to find out if number is between 1 and 5. So we can do something like this as well. So with integers, we can either do this one, or we can do 1 is smaller than or equal to number is smaller than or equal to 5. Anyway, the same basic principle applies to here, that we can write it like this, or we can write it. This is like more conventional way to write it in programming. Number is larger than or equal to 1, and number is smaller than or equal to 5. So if you don't want to use the AND operator in this place, you can just chain these operators one after one. And this is probably more familiar to you from mathematics. This is how we usually do it in mathematics when we display that number is or needs to be between certain other values. The reason why we usually use this one in the material is that in a lot of other programming languages, this doesn't work. In Python, it can also be somewhat problematic in some cases. Not in this case, this is perfectly fine, I think. And in this kind of example, you can actually use it. If you're testing that your number is between other numbers, or that your character or your string is between other strings or something like that, then this is perfectly fine. But in some occasions, it can get a bit misleading. But we're going to talk about those in the advanced course, I think. But anyway, this works in most of the other programming languages as well. What you need to realize is that if you want to find out if number is, for example, if the value of number is 1 or 3 or something, you can write something like this. But quite typical sort of misconception in the beginning is that you try to do something like this. And this doesn't check if a number is 1 or 3. It's so you need to chain complete conditions. If number equals 1 or number equals 3 or something like that. Okay. Then we can talk a little bit about nested conditions. Again, let's query the user for a number. And let's say we want to find out if the number is an even number or an odd number. And for that, we have the modulo operator. I think it was at least briefly discussed in the first week material. But the basic idea of a modulo operator is that, let's try this one first. So the modulo operator is denoted with a percentage sign in Python. And the idea of modulo operator is that it returns, well, the modulo of a number with this one. So basically it returns the result of integer division number divided by 2. And then it doesn't return the result of the division. It returns the remainder after the division. So in this case, let's take a look. If I give a 5 as a number, then it returns the remainder of division 5 divided by 2. 5 divided by 2, if we calculate with integers, is 2, and then the remainder is 1. So it returns 1. And if I provide 4 as a number, or 26, then 26 divided by 2 is 13, and the remainder is 0. And why this is useful is because it's easy to use it to check if the number is divisible with another number. And the really basic approach for this one is to find out if a number is an even number or an odd number. So what we can do is let's utilize it. Let's find out if number divide or modulo 2 equals 0, then we know that it's an even number, and if it doesn't, then it must be an odd number. And there are really no other choices because it's an integer, and if you divide an integer with 2, then the remainder is either 0 or 1. There are no other choices. Okay, and this one should work. Let's try it out. So I give 22 as a number, it's an even number, and 13 is an odd number. So that's a quick test. Let's say that it works. Now, there's typically, in mathematics, there's typically also the sort of assumption that even and odd numbers are only defined for positive integers. So, but our program sort of works with negative numbers as well. So -12 seems to be an even number, but what we want our program to do, we want it to say that this is a negative number, or it isn't an even number or an odd number. So let's test that one first. Let's find out if number is larger than 0. And then let's include everything under. So now only if the number is larger than, so now if I provide again 5, oops, provided over there, but over there. 5, then it displays it's an odd number, and if I execute it again and I provide 6, it's an even number. What if I provide something like -5? What happens? What's the result of -5? Yeah, nothing, no result, it doesn't do anything. We can actually fix it. Let's provide user something. Let's say that negative number like this, and then when we execute it again, now for -5 we get the negative number. So now we have nested if statement, nested conditional statements. So excuse me, this conditional statement in here is inside this other conditional statement. And this is really typical in programs that you need to have, and it's actually, when you have a bit larger program, you can have several levels of these nested if statements, one inside another. And one thing to be really careful, or where you should really pay attention with this one, is to check that you're writing all the else and elif statements on the correct levels. And in Visual Studio Code, for example, there are these lines over here which sort of try to give you some kind of visual hint on which belongs to which one. So this else belongs to this if. So something typical sort of error could be something like this, that you're writing an else statement and you want to write it for this if in here, but instead you write it over there. And Python doesn't consider this an error, but this of course is an error because you can't say it's a negative number based on this one in here. So it should be in here instead. There's a question. So I can make a block inside another block. Is there a limit to it? There really isn't. At least there's not a given limit to that one. It might depend on your Python interpreter whether it at some point decide it doesn't accept anymore, but there isn't any like given limit. Anyway, there's a sort of a practical limit that when you have a lot of these nested, at some point it gets really difficult to read the program code. And in that case, you probably need to figure out a way to do it with some other mechanism. But it's perfectly fine to nest these as much as you need them to be nested. Just as I said, you need to remember to be careful when you're writing these to find out that you're actually referring to correct level, correct if or elif or whatever statement when you're writing elif and else statements. Okay, then the final thing we're going to learn about this week is a simple repetition or loop. And again, this is something I mentioned briefly on the first lecture. In the beginning, I stated that computers are sort of stupid, but computers are great at repeating simple instructions, simple operations over and over again. And that's why repetition is so important in programs. And we start the repetition with a simple while loop, and we write it in a form of while true, which basically means that this block is executed over and over again until we explicitly state that break this block or end this block in here. And let's write a program that queries the user for numbers again, because that's what we've been doing today. And then it displays the, well, then it finds out that if number is even or odd number, something like that. And before it checks for that, let's check that if the number is a negative number. Now this is a bit different to the previous example. Now in this case, let's just break out of a loop and let's change the input query as well. Negative number stops. And now what happens when I execute this program? It seems to be behaving a bit different. So I can give a bunch of numbers. So it keeps on repeating itself over and over again. So for each number I give 123, it's an odd number, 444, for 6 is an even number, and so on until I provide a negative number, and then the program is terminated. So how we use blocks, or how we use this repetition at first is that we write a while loop and we provide the true as a condition. Again, this is something we're going to change a bit. Do it like this to make it more Python-like. Sorry, and this loop will keep on repeating until we explicitly state that stop, and we do it by having a break statement in here. And this break statement means that this block is immediately terminated, or this loop is immediately terminated, and then the execution continues in here. You can have a thank you message over there. Let's try it out again. So let's see, 2 is an even number, 3 is an odd number, 5 is an odd number, and minus 66 means that the program is terminated, and then message of thank you is output. And this is what we start with. This is enough for this week. We can write more complicated loops, and some of you, a lot of you probably, realize that because there's a true in here, then that needs to be some kind of condition. And yeah, we can have conditions in there to come up with more versatile and more sort of flexible loops. But we're going to talk about that next week. So let's start with this one. And a loop like this is actually quite useful in a lot of occasions. And something like this is a typical example. The program where we query the user for stuff and keep on repeating that until at some point with some input value we want to terminate it. In this case, we decided that negative number is a good input value to terminate the program, because we can't define, we don't know whether negative numbers are, or we haven't defined negative numbers as even or odd numbers. But for any other input value, we check if it's an even or odd number, and then the execution continues from here. Like we see, it keeps on repeating the same code over and over again. So there are some sort of a simple examples and some simple exercises about this one, and then we will continue on more complicated loops next week. And that's basically all the stuff for this week. As I said, next week we're going to discuss loops a lot more actually, and then we're going to talk more about strings and string operations and things like how we can extract strings out of strings and substrings and characters and some string methods, and then own simple functions. Someone asked for recommended extensions for using Python in Visual Studio Code. You don't necessarily need any extensions as long as you have Python installed, and you can download Python from python.org, if I remember correctly. Anywhere there will be detailed installation instructions on how to use Visual Studio Code in week 4. But if you want to start using it before then, and I think it's not a bad idea if you want to write your own programs or anything like that, just download and install Python. Just type download Python into Google. Okay, so my voice was cut off okay, let's just reverse a little bit or go back a little bit. So what I was saying, that if you want to, so there will be detailed instructions on how to use Visual Studio Code in week 4 of this course. If you want to start using it now, you need to install Python. You don't specifically need any extensions at this moment. You will get the instructions on how to install the TMC plugin, which is displayed over here in my VSC later. But just type download Python into Google and download Python for your own computer, download and install it, and then install the Visual Studio Code, and it should find Python as is, so you can keep on or start working on Python programs. So it doesn't necessarily need any plugins if you don't want to. I don't think I have any Python related plugins, any like plugins related to basic Python in this computer. Okay, any questions about the stuff we were talking about today or anything else? So there's a lot. Basically, what we think, what is the topic of the second week is a lot more flexible conditions, and then simple loops. And there's a question: when will the next week's part get unlocked in the MOOC? We unlocked this one yesterday. Basically, what is sort of the promise schedule is that it will open after this lecture. So when the lecture stops, the next part should be open. Usually we get it open at Monday. We actually sometimes we might get it open before weekend. So we're basically doing the translation from the Finnish stuff at the same time when the course is going on. We have a translators meeting every Friday when we check that what's done and what needs to be done for the next part. If everything is in order on Friday, we can open it at Friday. Usually there's some small fixes what we need to do over weekend, so we basically do it on Monday. But it's also possible that at some point the schedule might be so tight that it won't be open until the lecture starts. Well, sorry, lecture ends at Tuesday. So that's the latest, but we open it. Each week is opened as soon as possible, so you can gradually take a look if you want to, if it's open already. Any other questions? If not, then I'm going to stop my screen share and let's stop the recording.